What's up guys, back with another video for review of Physics 2 Summative 2 test. We have a simple problem for capacitance. Okay, let's get to it. It's actually much simpler to analyze. So let's just look at the thing. These are just values that I made up. This is actually really quick to do. I just whatever. So here we have C1 and C2, since they have one straight line. Remember from my first video and from my master guides, C1, C2. Since they're in a direct connection, they are in series. And we can write that down. C1, 2 is equal to this. Oops. Why is it like this? Remember that for capacitors, when you add them, it's like this. The reciprocal of the reciprocal. So yeah, the summation of the reciprocals, and then it's reciprocal. So 1 over C1 plus 1 over C2 raised to negative 1. Alright, so what other equation can we get here? So remember, in circuits, you always want to get your R total or C EQ. By the way, EQ is basically your total. So how can we get our CEQ? So we add our capacitance from here to this. But you see here, this is a parallel connection. Why is it a parallel connection? Remember what I said in the last video? Why is it not switching? You see here, so parallel. Oh, there's this thing here. There's this thing here. It's because it has multiple directions. If you have a series connection, it's just one straight line. But you see here, since there's this intersection, it's a parallel. So yeah. And for parallels in capacitors, you just simply add them. So our CEQ is equal to C12 plus C3. Then again, the process, we structure our other equations. So for Q is charge. Q functions the same way as current. Let me say like current. It functions the same way in capacitance circuits. So Q12 is equal to Q1 is equal to Q2, because in series, remember that the charge or current, they're equal. So next, QEQ is equal to Q12 plus Q3. So parallel, you add them. That's in your formula card. Let's make this quick. V is V. Voltage is your voltage. Remember that in series, you add the voltages. So V1 plus V2, and then VEQ, because V12 equals to V3. Remember, just you structure them the same way. Copy the subscripts, and bada bing, bada boom. That's solve. So C12. Oops. You have 1 over 5 micro. What was it called? Besides this shit. Micro. Wait, why am I blanking? But that's not 5 micro. So 5 so remember, if you're just adding micro and micro, you can just add them. You don't have to convert them just yet. You convert them when you're dealing with other values. I'll show you later. So let's have 1 over 5 micro plus 1 over 10 micro base negative 1. We have our C12 which is 3.33 microfarads. Since we have our C12, we can get our CEQ. We follow the equation here, the formula. 3.33 micro plus 12 micro is equal to 15.33 microfarads. And we can write that down. I think in tests, I mean, I guess this is acceptable, but you can just write this as times 10 raised to negative 6 already. Remember, that's the conversion for micro. Next. So, remember, I forgot to erase. Yeah. Remember, if you have two values in a column, you can get the third one. So we have here our CEQ and VEQ. We can get our QEQ. Do the formula C equals Q over V. We do this 15.33 times. Remember, so you can convert it now. Times 10 raised to negative 6 times 67 voltage. That gives you this 1.03 times 10 is negative 3 coulombs. Remember, coulombs EQ. Okay, this is the part where we just analyze. We analyze now. We look at our equations and see whatever bullshit we can come up with. We look here. Oh wow, our voltage, total voltage, is actually equal to our V3 and V12. It's like the first problem. So let's go do that. So our V3 is 67 voltage. So since we have two values, remember, we can get this one. That is our 12 times 10 raised to negative 6 times 67, 8.04 times, what's this? 10 raised to negative 4 coulombs. Pretty simple. So we analyze again. We want to get our Q1, Q2, V1, V2. How can we get that? So you look here. We can get our Q1, Q2 if we have Q12. How do we get Q12? It's simple. Yeah. There are actually two ways you can do this. So I remember the first problem. What you can do is you transpose Q3, so QEQ minus Q3, or you can do the other way. Either way is correct. Q12 is also equal to C12 times V12. Yeah, both are correct. This one, so because here, remember, we solve for C12, and we have V12. Yeah, because remember, V12 is also equal to your V total. You see here, 67. So you just multiply those. And remember, you can subtract. Okay, you can do this one. So a Q12 is equal to 2.23 times 10 raised to negative 4 C12, and you see here, you state that it's also equal to Q1 and Q2, right? So there we go. And then the easiest part, just 5 times 10 raised to negative 6 times this. That'll give you 44.6 voltage. And 10 times 10 raised to negative 6 times your Q2. That'll give you 22.3 voltage. Remember, look at the part. If you want to double check if you're correct, look at the part where you have a series connection. Look at its voltage. Its voltage, when you add these two, should equal to your total voltage. It's not gonna be exact, but it's right there. 44.6 plus 22.3, that gives you 6.9, which is like this already. So there you have it. I mean, remember, this is the master guide. This is some examples I made on identifying series and parallel. Both important. Don't forget to like and subscribe. I made this for my beautiful girl. Thank you.